So, we're most of the chapter, or some of the chapter, is going to be talking about logarithmic functions, but we start with exponential functions. Okay, so those are important. We've seen that with the pandemic. So, if you had looked at charts of cases of people that had COVID-19, you'll see over time it goes up very quickly. And we call this an exponential function. Okay. Um, they don't have to go up very quickly, but that's one type of exponential function. Okay, so there's a graph here, and it's mall browsing time and average amount spent. So the idea is, well, the longer you're at the mall, the more money you're going to spend. And they find that there's an exponential relationship here. So here's somebody spending a half hour, they're spending $47. But when they're 3.5 hours at the mall, they're spending like $200. Okay. So later today, I'm planning on going to the mall. We'll see if I go, and I'll report back if I do. All right. So exponential functions come in this form. They say f of x is equal to some base b. And has some restrictions on it. And then the variable x is in the exponent. That's what makes it an exponential function. Okay, so um, that's what's really important right there if it's going to be an exponential function. Things like inflation work this way. There's other examples in the real world. Okay, and we'll see some of that in this section. Okay, there's some restrictions on b though. B has to be greater than 0, so it has to be positive. And b cannot equal 1. Okay, so why is that? Well, if it's negative, if the base were negative, you're not going to get the same output. You're going to get like positive, negative, positive, negative. It's going to oscillate like that. So you're not going to get like this um, continuous trend, okay? And if b is just 1, well, what's 1 to any exponent? It's just going to be 1, right? So you're not going to have any change. It's just going to be constant on the output. Here, it's the output that's oscillating. Okay, so it would go positive, negative, depending on your value for x. Like if you were just using integers, that's what would happen. Okay, so those two things apply. X, by the way, is a real number. Okay, so what looks like an exponential function? Well, you could have f of x equals, you know, 5 to the x power. That would be exponential. G of x equals 1/2 to the x power. That would be exponential. H of x could equal, well, I'm going to put this in here, -3 to the x plus 1. That is an exponential function. So notice that the 1 is up in the exponent. It doesn't have to be, but that's how I have it written. You might be saying, hey, wait a minute, b is negative, but b is not negative. B is just 3. Remember, it's just the 3 that's being raised to that exponent. And the negative is in front of it. We'll talk about what happens when that happens. Okay, so what are not examples? Not exponential functions. Those are all exponential functions. What's not an exponential function? Well, we've had functions like f of x equals x squared. That's not exponential. The variable's not in the exponent, it's in the base. Okay, so this is not exponential. -1 to the x power. Nope, that's not exponential because we said the base has to be positive. It has to be greater than 0, so not exponential. H of x equals 1 to the x power. Nope, not exponential. We said the base can't be 1. Okay. And then k of x equals, let's say you had x to the x power. That's not exponential. You do have the variable up in the exponent, but you also have this variable for the base, and the base is got to be a number. Okay, so it's a real number, and it's got to be positive, and it can't be 1, but you could have. Okay, so base is a real number. But it has to be these conditions. It has to be greater than 0, and it can't be 1. Okay, so now let's look at an example. It says the exponential function f of x models the average amounts spent in dollars at a shopping mall after X hours. So that's what we were talking about with that graph. What's the average amount spent to the nearest dollar? So we're going to round to the nearest dollar after 4 hours. That is your X then. Your X is 4. Okay, so we're going to go to the mall for 4 hours. How much money do we think we're going to spend? This model predicts that. So we're finding f of 4. X is 4. Now, you're going to be doing a lot of calculator work in this section because we don't do these by hand. I'm not going to raise 1.56 to the 4th power by hand. That would take me all day. Okay, so I grab my calculator, and I just have a cheap calculator, like $10 or something. It's not even a great one, but it's a Texas Instrument, and they're pretty good calculators. So, all right, how do you put this in your calculator? Well, that's the trick, right? And calculators are different. Casios are really popular right now. They work very similar to the Texas Instrument ones. Um, if you have a different type of calculator, then it will probably work as long as it's scientific. It has these functions. You can actually do this on your phone, like on my phone. And I have an old phone, but I can, put it in scientific mode and it'll do the exponents for me, and it's not too bad. Okay. So how do we put this in? It's 42.2. So you're going to put that in. 42.2. There, I put it in. And then you can either open a parenthesis or you can just hit the multiplication button. So I'll be using the star to indicate multiplication. I usually like to do that. And then I'm going to put 1.56. Here I go, 1.56. And then my calculator has this button. That's the exponent button. So I think we've used these all before, but just to go over it. And then I'm going to put 4, and then I'm going to put enter. So mine says enter, or it could say equals. I think my button says both actually. Okay, so I plug that in, and I'm rounding this to the nearest dollar. Now I got 249.9256581. That's what my display says on my calculator. Yours could have more numbers, it could have less numbers. A lot of calculators, it allows you to set how many digits it's going to show. But I have to round it off to the nearest dollar. So I look behind the nearest dollar. The nearest dollar is going to be right there, the ones column. And it looks like it rounds up. So it's going to go from 249 to 250. So I'm planning on spending approximately, if I'm there for 4 hours, I'm going to spend like about $250. Okay. So that's a little bit of work with the calculator. If you have any troubles with your calculator, come to office hours. You can Zoom it and I can go over that real quick. Or you can call me during office hours on my phone, and I could answer your question that way probably. Some calculators have a Y to the X button instead of the little mountain button. Okay, so this is a button on the calculator. This is a button on the calculator. Okay, so hopefully you won't have any trouble, but if you do, let me know and I'll try to answer your questions, or you can email me too.